But as we get older, you lose the ability to respond to things, and that sets up a stress in your body. In the long run, I would like to be looking at, certainly at dementia. I'm very firmly of the belief that science is for everybody, and if there's something you want to do, you should grab it with both hands because we get one go here.
Lorna Harris, the Chief Scientific Officer of Senisca. Thank you for coming.
You're welcome.
And Senisca, this means senescent cells.
Yeah.
And on this Rejuvenation Startup Summit, there are 4 startups fighting against senescent cells. It's the new trend?
I wouldn't say necessarily it's a new trend, actually. There's quite a few people who've been working on this behind the scenes very quietly for quite a few years now. But I think when the initial papers came out that demonstrated actually this was a tractable target for the diseases of aging, I think it's an obvious place really to look.
Perhaps very shortly explain senescent cells.
So I think the popular media like to call them zombie cells. I'm not sure I like that definition, but I think it's actually quite apt. So they're cells in your body that accumulate as you get older, and that wouldn't be a problem except they talk to all of the other cells and they throw out chemicals which basically tell all of the other cells to also do the same thing. And it's that cumulative signal, that additive signal of all of those conversations between the cells that are one of the things that drives aging in organs and in people.
And when we are young, senescent cells are very helpful, huh?
Indeed. So this is one of the challenges actually with this therapy, is that there's not just one type of senescent cells. There are ones which are useful, certainly when in embryonic development, when that baby is growing, there are things which are crucial for senescent cells are crucial for. And actually, even as we are getting older and during your life, you need senescent cells for things like wound healing, actually. So they're necessary, at least some of them are necessary. But the problem with the ones that we're looking to deal with is that they don't know when to turn it off.
Yeah, and you are working on the signaling pathways and also on the processes why senescent cells, when we age, are in excess.
Yeah, so one of the provocations that makes cells senescent is stress. So if your cell is happy, it's got nothing shouting at it, it's not going to do anything. But as we get older, our academic findings have shown that you lose the ability to respond to things, and that sets up a stress in your body, and stress is one of the provocations that makes your cells senescent.
Yeah, and you are working on a technique to heal a process which is creating senescent cells.
Yes, broadly speaking. So our team work on a process, it's called splicing, which is part of the decision-making process that the cell makes, what to make in order to respond to that stress. As we get older, we lose our ability to make that decision, and the cells are not able to roll the punches, to make what they need to. We're just restoring the ability of the cells to do that and relieving that stress, which allows the cells, at least some of the cells, to recover some normal function.
Seems to be easy, is very complicated. So
none of this is easy.
The splicing of the RNA is a really interesting process. It's a genetic process, or it's caused by genetic. How did you find the molecule, the oligopeptides?
Yeah, so my lab, my academic lab has been working, we're a splicing lab, that's what we do. We've been working on splicing for a very long time. So we knew what the genes were that were encoding the things that make the decisions. So the oligos that we designed are specifically placed in a region of the gene that allows us to restore its activity.
Incredible. How did you find this molecule?
So if you know where to look in the gene, so it's it's know-how, it's knowing which bit of the gene you want to target. We knew that.
How far are you now?
So we're at the stage now, we are in the ex vivo, in vivo phases. We've got some lovely data emerging in tissues, living tissues from people.
In skin?
No, this is actually in lung.
Ah, in lung fibrosis.
In lung fibrosis. Yeah. And we have also done some work looking at to make sure we can get our oligos into the lung and that they stay there and that they don't go everywhere else. Because actually for a targeted therapy, you don't want everything everywhere. You want to be able to say very precisely where it goes.
How do you bring them into the lung?
They're inhaled.
Mm-hmm. And they're staying there?
Yes.
Okay.
So these are relatively new data, but the data that we have show that with the chemistries that we're using, the particular building blocks of those oligos that we're using, we can deliver to the lung very effectively, just actually up the nose. It will stay in the lung for at least 7 days, and it doesn't go anywhere else.
In future, this very complicated, easily sounding compounds, which age-related diseases will they target?
Sure. So in the first instance, we're looking at idiopathic pulmonary fibrosis, which is lung fibrosis. We're also looking at a dermatology indication, a skin condition, which is after radiation therapy, you sometimes get wounds that won't heal. So we're looking at that. In the fullness of time, though, we have to focus on one thing at a time, and we have to start. None of this is easy, as you say, but we have to start with the things which are more within our grasp. In the long run, I would like to be looking certainly at dementia. I'd also like to be looking at osteoarthritis in the long term.
And as a prevention, so that everybody who gets 40 or 45 takes your oligopeptides, not getting for prevention.
Yes. So we do know from our academic work that actually if you mess with this process in the younger cells, they don't age as quickly. So we know that it would work. The challenge that we would have to get over for that is the systemic delivery. It's getting it everywhere. So that's a challenge at the moment with oligonucleotides. Whether or not we did that with an oligo or whether we used a molecule for that targets the same process, we'd have to have a think about that. But I think there's certainly an opportunity there. One of the nice things about dealing with senescent cells is if I deal with the senescent cells in the lung, there's a lot of data out there that says actually because of the fact the cells talk to each other, you have benefits systemically.
Incredible. And what's about funding, investors' money?
Sure.
How,
always happy to talk to investors.
How complicated is that?
Actually, we've been quite lucky so far. I mean, we're about three and a bit years old now. We have had 3 successful seed rounds. We've brought in about 7.1 million or thereabouts. We've had some really good support from our investment base, really good follow-on support from our investment base. We've just shut a round in February. That will keep us going for about 18 months or thereabouts, and we'll be back out on the campaign trail probably towards the end of the summer, ready for our Series A.
And how long do we have to wait until we have the product?
So for the therapeutics, by necessity, the regulation being as it is, we're probably looking somewhere in the 7 to 8 year mark. But we do also have another sideline, which is a small molecule chemical sideline in the skin health space. Mm-hmm. That one we're working up with as a co-development, and that one is a lot nearer market. So we're probably looking about 2.5 years.
And tell me about you personally. Since 20 years you are in this field,
yes.
Research and development.
Yes.
And it's so wonderful, you're a role model for so many women, So many women that say, oh, chemistry not, but genetics and molecular biology, we hate it. You are so happy with that job.
I love it. I really do. It's my favourite thing to do. I've never really wanted to do anything else. And I appreciate what you're saying. There are barriers actually to women going into science. I think sometimes people, not just women actually, there are people who don't go into science because they don't think it's for them. I'm very firmly of the belief that science is for everybody. And if there's something you want to do, you should grab it with both hands because we get one go here.
How many women do you have in your team?
Oh, we're pretty women heavy actually. So that 2 of the 3 founders were women. We have a female CEO, obviously myself, and then of our research team, the vast majority are women actually.
Great. That's the future.
Don't tell the boys.
Thank you very much.
You're very welcome.